Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. What's up, Gophers? It's not too late. If you're planning to attend KubeCon Cloud Native Con here in North America later this November, know that we have just entered late registration pricing, but you can still save 10% off your registration when you use our code KCNA-changelog19. Again, that's KCNA-changelog19. Check the show notes for links to learn more and register. Welcome to Go Time, a podcast featuring a diverse panel and special guests discussing cloud infrastructure, distributed systems, microservices, Kubernetes, Docker, and also Go. We record live every Tuesday at 3 p.m. Eastern, noon Pacific. Join the community that's live with us in real time during the show in the Go Time FM channel in Gopher Slack. Follow us on Twitter, we're at GoTimeFM. Listen live at changelog.com/live or subscribe at changelog.com/GoTime. And now on to the show.
Hello there, and welcome to Go Time. I'm Matt Ryer, and this episode is all about application design. I'm joined by a concurrence of Gophers, which you may already have read about and met, maybe, and seen videos of and all sorts. So I'll introduce them now. The first one, welcome back, Peter Bourgon. Hello, Peter.
Hello, I'm speaking to you from my Berlin dungeon, this time in a slightly less echoey chamber of it.
Lovely. Nice to have you again. We're also joined, it's Kat Zień. Hello, Kat.
Hello. Wow.
How are you?
You actually pronounced my name right this time.
Yeah.
Have you been practicing?
I have been practicing, yeah, because the letters in your name don't help. So I had to practice. They don't help me.
Hello, everyone. I'm joining from my flat in London.
Awesome. Welcome. I also want to go around and get everyone's Twitter names as well after, in case anybody wants to, send love or hate on anything you've said. My final guest, last but no least, it's only Ben Johnson. Hello, Ben.
Hey, glad to be on here. I'm representing Denver out here.
Lovely. And how's the weather over there in Denver today?
That's great. Sunny as always.
Yep. I lived there, actually, believe it or not, for a while. Yeah. Well, welcome. We're going to be talking about application design. We're going to be covering, I think, I'm interested in what principles that there are that we can apply. I know that a lot of decision making when it comes to the design of applications is really more trade-offs than there being strict right and wrongs. So I'd love to dig into some of that too. It would also be great to hear about some common mistakes that we see and that we've made ourselves in the past, as well as any sort of specific patterns which people can apply today to their work. That would be excellent, so no pressure. But let's kick things off. Principles. Are there any that stand out to anyone? Things that you think are probably the most important things to consider when it comes to application design?
So I'd like to back up half a step, actually, and observe the things that you observed. What it was like principles, set and setting, this sort of thing. Another thing that I am increasingly aware of when I talk about, how you should design your application is the context in which you program. So like if you're writing by yourself and just kind of like exploring a problem space, the rules are completely different than if you're on a team of like 20 people working for a Fortune 500. And they're completely different if you're working on an open source project with, 100 maintainers that drift in and out. And I think we kind of often fail to bring up our contexts when we talk about what's good and what's bad. And I think that more than anything is like behind a lot of our opinions. So I try to do that. I often fail. Maybe that's something that's worth talking about.
I think so. And I would extend that also to the life cycle of the project itself as well. Even if you are in a big company, at the beginning of a project, you probably would do things differently and they will change over time. And hopefully they change in response to real feedback from the code and things. So yeah, I think that's a great point. The context matters. And I think When the context is removed, that's when we end up having kind of arguments and disagreements about things publicly on Twitter or in person. And often it's because we're just looking at it from a different context. And so that's what I mean. It's not really right or wrong. It's sort of a trade-off.
Yeah, I very much agree.
Yeah, I think that also explains why there's very rarely like a right or wrong answer. Like the answer is almost always, it depends on what you're building, who you're building this with, like all those things that Peter mentioned. And I think that's kind of why I'm never a fan of the always or never rules. Like if somebody tells me, oh, you should never do this, or you should always do this, I always reply with, well, if it fits your use case, then if you have a good argument for it, then you should do it or you shouldn't do it. So yeah.
Totally. Except globals, you should never use those.
I knew he was going to say that. Yeah, globals, yeah. Actually, that's an interesting... We should maybe start there, because I think, Peter, you did a tweet once, and I always have this now in every one of the talks that I've done since then. And you were essentially, saying, if you avoid global state, you kind of can cut out a whole class of issues that otherwise you might encounter. That helps with testability, it helps with reasoning. It does kind of make things sometimes a little bit more verbose, but it's probably worth it. So does anyone disagree? Do we all agree that global state is a bit of a painful thing?
Yeah, I can't think of many times when you need it. I mean, there's some stuff with like, database SQL where you register drivers, but I mean, that's another issue we can discuss as well about whether that's the right way to do it.
Yeah, so that's a good point. I mean, for me, anytime you like import a package and there's side effects to that, that's the sort of magic that I like that in Go we don't have that sort of magic, I know it's a bit more painful, but I don't think there's anything wrong. And they do this in the image packages too. If you want to support JPEGs and PNGs, you just import those packages with an underscore. I wouldn't mind if you had to import the package and then call a method to register something. I feel like that would be more explicit and better.
This kind of like boils down to the like thesis of application design that I've kind of wound up at after a lot of years writing programs in essentially like corporate environments on small teams, which is packages should store declarations like type definitions and functions, and only like in your func main should you store state. And if you keep to that rule, it kind of like you said, Matt, a lot of valuable things kind of fall out. Testing becomes easier. It's a lot easier to read a program top to bottom and understand what's going on, blah, 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 blah. I can go on at great length about this. And a lot of people think, well, if I just quickly throw a logger in the global state, it's very easy for me to use. But I've written a lot of programs where there's no global state at all. And like the cost of typing the keys just never enters into the cost equation for me, especially if the program's going to be running in production or something for a year or 2 or 6. It's just like the cost of typing just never enters into the cost equation for me. But again, this is my context, right? And a lot of other people who are writing shorter-lived programs or whatever have different contexts.
Yeah, I used to always start, applications where I had like a main struct that kind of almost held things in, or I'd even inject like standard in, standard out just to be able to test those and do loggers. And like, I've kind of backed off that. Like I'll get to that when I need it, like when it's grown big enough, but I try not to start, going crazy at first.
That's interesting. So talk a bit more about that idea of injecting standard in, standard out. How would you literally do that?
Yeah. So I mean, one option which you can do is so if you wrap, you can make a main struct. This is one option where your main struct basically has your standard in, your standard out, kind of contains that state. So that if you wanted to run tests against your main package, you can actually instantiate that and then assign the actual, buffers into that, readers into that, and then be able to check for log messages, all kinds of little tidbits like that.
So you're taking an IO reader for standard in and an IO writer for standard out and standard error, and then you can use any types that implement those interfaces.
Yeah, that's pretty handy.
Yeah. You see, I do this thing where I still do this regardless of the size of the project. I like returning an error, so I immediately in my main call out to a run function that can return an error, and then all my code in that run function just returns errors in a normal way. In the main, sometimes I like to write the error to standard out, and maybe I'm going to exit with a non-zero exit code, and I only have to do that once then. And sometimes I'll take arguments into that run function, like arguments, for example, if it's a command line and I'm going to be parsing flags and things, passing them in. And that allows you in tests just to call that run function like a normal function. It's nothing special about it.
Yeah, I do the exact same thing. I think I saw a tweet from you, and my code looks almost exactly the same when I set up a main.go.
So I'm wondering about a slightly different use case. So, because obviously the run returning an error, it works for a simple application that can just return an error. But let's say you're writing something that processes requests, and then you take in a request to return a response. Then it kind of becomes a little bit more complicated because just returning an error doesn't really solve your problem or use case. So what I've seen done is basically just a similar principle, but instead of having like a clean one error returned at the end, you just return the error response. So you kind of wrap the error in the expected HTTP response. Same principle, but you kind of adapt it to the particular thing that you're working on.
Yeah, so it's like a tiny abstraction, not going too far, but yeah, and it probably would be different, and is actually. In cases where I'm not going to read anything from standard in, I wouldn't have that as an argument. And that's a storytelling opportunity too. It's clear then what this program needs and what it's going to use. Yeah, I do wonder if we could just sort of maybe get rid of global state. If we ever did a major release of Go where we could make big breaking changes, what about just getting rid of global state? Just don't allow it. What do you think about that?
Yeah, I'd be okay with that. I'd have no problem with that.
There's a use case for like global const, right? And the current semantics of the language require you to use var for like maps, right? You can't say const map. But if we could somehow magically fix that stuff, I'm all on board. And of course, this also means eliminating the init function, which is the source of great suffering.
Yeah. We've kind of jumped straight into sort of common mistakes. Maybe we should keep going with this little thread because it's quite interesting. And I think, again, it's worth saying that if you do... Part of my approach with the team is always, it's okay to make mistakes. We'll start simple. And if we do make a mistake, we just have to be ready at that time to, once you feel that pain, then it's worth fixing. And that approach also helps you avoid going too far in the beginning as well. Like you're not spending all this time building out this big, complicated architecture thing that you're never actually really going to need.
One of the first talks, I think, about Go was by Andrew Durand early on. It was called Code That Grows with Grace. And he kind of laid out the evolution of a program from something extremely simple to something that was moderately complex. And the point was, at every step of the way, don't write more program than you need at that step. And I think there's great value in that.
Yeah. It's not a failing. Like people try... I think what happens is we look at successful projects and we can, because it's a lot of Go is in the open source world, you go and have a look and you see all this structure and stuff, but hopefully that's there for a reason and it's sort of organically grown into that rather than it being designed that way from the very beginning. So, and you're probably not in that situation yet, so you don't have to do those things. So I think that's the same kind of principle. Yeah, I think it really applies.
Yeah, I've been doing these office hours recently with just Go folks, just talking to them. And it's been interesting to see some of that approach where it's like they'll see the world as it's going to be in a year or two, and they want to plan for that. And they've broken out into 20 microservices and all that stuff. And it's just, I find it hard to break out microservices as it is, but without having the context of what things really interact in your application and really understanding as a whole, I feel like you need to grow into that for sure.
Yeah, I think it also applies to what the programs and what the projects are doing as well. Like start on that core, the thing that's the most valuable, and don't try and solve every problem under the sun. But again, let that stuff evolve and organically grow as well. There will be times when you have to go and correct things, like you've made bad assumptions or whatever, but that's just totally normal. That's the thing, I think, when that happens to people, especially if they're new to building projects like that, they feel like they've failed somewhere and they haven't. And I think that's quite an important lesson.
There's a really lovely blog post article or something by a programmer in London by the name of Tef. I don't know his real name offhand. And it's titled Write Code That's Easy to Delete, Not Easy to Modify or something like this. And he goes into quite some detail about this. And I'm totally on board with this idea. The program as it exists in any given moment is the best approximation of what should exist for the understanding of the domain model. And when you have new requirements that arrive, you should be very eager and it should be very easy to delete and refactor all the abstractions that you've done so far and rebuild them with your new knowledge. You shouldn't feel like trapped in the structure that you created without really knowing what you were doing. So I highly recommend that article, not for Go, but just in general.
Yes, which I think is probably one of the most valuable things you get from microservices, is that in theory they're micro, they're small, and if it's not doing what you need it to do, you can delete it and rebuild it, rewrite it. If I'm writing a package that's going to be an open source package, genuinely, I will write it once and then I kind of know what it needs to look like. I know what it is, and I'll actually write it again the second time. Usually trying to cut the fat, trim the fat down, trying to make sure it's just the essence of the package and shrink it as much as possible and things like that. If you try and do that from the very beginning, sometimes you can, and sometimes you see little shortcuts to make, but it can get in the way of that sort of process where you're exploring. So you should definitely be free to just explore and get that problem solved. And then afterwards you can go and I rewrite it literally. I mean, there's a quote from Hemingway, I think, which he said, "The art of writing is rewriting." And I think that applies to software as well. You can't always do it because, in the real world with teams, we don't always have the luxury of time, but it's so worth it that it's actually, I always encourage teams to deliberately build in time for it, just because the results are so much better.
Yeah, I completely agree that coding for the future is the number one problem that especially I think junior developers have. Like they try to anticipate everything and then I really try and encourage them to just think about the problem at hand and worry about other things later. And I think that what you said is right, is that you shouldn't really expect to get it right from the start, because especially the bigger the problem, the bigger the application you're building, like it's very hard to just get it right from the start and predict absolutely everything and how it's going to look like in a year. A lot of the things come out in the wash. But I think just applying some good principles from the start will let you then change that code much better. And I think it's very, very important to just try and draw from your own experience. Like if you've already encountered that problem before, you probably have some experiences with that and like you've hit those pain points before. So I think it's fair to then say, oh, I'm going to do this right away because I know that this will let me solve that problem later on or avoid these kind of problems. And that's fine. And then if you sort of recognize the problem that you've had before, it's easier to do that. But if you haven't actually done anything like that before, then yeah, the easiest way to start is just keep writing. And then at some point you stop, you take a step back and then you think, okay, maybe like now we have enough to now think about the design a bit more and structure it a little bit better.
Yeah, Kat, you had a great talk basically going through an evolution of, was it like not design patterns, but like architectural patterns, I guess.
Pretty much, yeah.
Yeah. What was it called again?
It was how do you structure your go-ups? Basically different, like there were 4 different layouts. So I think layouts is the right term. So yeah, it was a flat structure. It was grouping by functionality, grouping by context, and then the hex architecture, or like sort of talking about DDD and hex architecture as like the final, like my personal favorite and holy grail. But that's not to say that the flat structure isn't valid or good. It's equally valid and it's equally good. Just depends on the problem.
Right. In GoKid, which is like a project I maintain, a lot of people jump into it when they're like just getting started with their like domain idea. And like, it's not for that, right? It is the final stage when you totally understand things. And so it's totally fine to, I think, start very small and don't have a complicated structure before you know what you're doing.
Yeah, I had this experience recently where I knew there was going to be some structure. I knew that there was going to be some complexity, but I couldn't quite imagine it. So what we did is we just had everything just in one folder. That was it. And once we'd got down the line enough that we had the thing working, some concepts which were quite surprising, they sort of presented themselves, and it was then quite easy to see how it should be structured. I wasn't able to do that before. So yeah, and if listeners take away anything, it's that we shouldn't be imagining stuff too much. We might get it right, but we might not.
One of my favorite ways to refactor, like I'll start with a flat structure and I'll just put way too much code in there. And then eventually at one point just open Go docs. And a lot of times you can just look at the names and it's like, oh, I have a MySQL something or other, MySQL something. And it's like, oh, well, all these things are prefixed with the same name. They probably are kind of related. Maybe that can be a structure, and just try to figure out where that kind of falls out.
I think we're kind of talking about, in a sense, like abstractions. Like where do we define the abstraction boundaries in our program? And like one thing that took me a long time to learn, but I think is really true, is that abstractions have to emerge from the program. You can't like apply them from day one. You have to like, they have to be revealed from what you build. So like premature abstraction is the root of all evil.
Yeah, I think it's also really important to like really take your time to make sure that you understand that the problem and the domain that you're dealing with. And like I've had it so often in the last few months where I'd be given a task to do, or like I need to get something done, and then I would immediately jump into the things that I think I know, and like I would do it this way. And then you just take a step back and you ask the question of like, but does it actually address the original problem that we're trying to solve? And then surprisingly, most of the time you're like, oh yeah, maybe we don't actually need to do this, or we can just do that. So I think it's also important to not get too tied to like your usual ways of doing things, or like because you always do things that way, then because sometimes you might surprise yourself when if you take a step back and actually like zoom out of the code a little bit, and then you kind of see new patterns emerge, or, you know, maybe a new grouping that would make your life easier in some way. And also like just thinking about, you know, does this actually address the problem that we're trying to solve with this particular application?
This episode is brought to you by TeamCity. TeamCity is a continuous integration and delivery server developed by JetBrains that helps software teams release their software faster, get fast feedback on every commit, quickly investigate build failures, and so much more. In this segment, I asked build engineer Oleg Garevich from Wargaming, who's been using TeamCity for 7 years, about what he loves about TeamCity.
So I love how easy it is to manage TeamCity on a daily basis. I don't have to hack any mysterious XML to configure it or make changes, though there is an ability to do that. I choose not to. I do most of my work through the UI. I also like the fact that I can customize a lot of its behavior, either through the UI or through custom programs that I wrote, or through plugins with their open API. I don't think I could do my job without the support that TeamCity development team provides. And I use that support at least weekly, whether it's for new features that I'm interested in or for bugs that we find. They're very collaborative, and honestly, over the past 10 years, they've made my job so much easier. I really owe them.
All right, to get started with TeamCity, head to teamcity.com/GoTime to learn more. The professional version of TeamCity is free, even for commercial use. For large orgs, you'll want to check out the TeamCity Enterprise Edition. And right now, there's a 50% discount for our listeners on TeamCity Enterprise. And as a bonus, if you want a personal intro to our friends at TeamCity, they'll help you through your CI/CD path. Email me, adam@changelog.com. Head to teamcity.com/GoTime to learn more and give it a try.
If you already have lots of, say, whether they're microservices or whatever they are, you already have things that you're working on and you're adding more of those, do you think it's best to just follow the patterns that are already established, just sort of for the sake of consistency? Or do you think it's worth using new learning and new concepts to improve things gradually? How do you feel about that?
I would say, personally, I feel like if you have a lot of microservices and you're not really quite sure about your structure, or a lot of packages for that matter, I feel like unless you kind of get the package structure right, packages kind of beget packages. Like because of the you can't do circular dependencies. So a lot of times you end up having these kind of third package to interface these two packages because they can't reference each other. And you just get this massive onslaught of packages. So honestly, sometimes I recommend people just actually consolidate when they get to where it explodes too far, and then kind of come back and revisit.
Yeah, that's a great point. I don't like it when you have a package that's there really just to make the compiler happy, because we're not really writing the code for the compiler, are we? We're writing code for our fellow humans.
I think my number one advice to somebody who has microservices is to keep them, I think the official term is homogeneous, which means exactly the same. They're just a carbon copy. And I think a step forward from that is just use code generation to just spin up a brand new service that has exactly the same structure for a bunch of reasons. So one of them is familiarity. So if you have 10 microservices, maybe you can memorize, how each one is structured. If you have 1,000 microservices, it makes your life a lot easier if you can just open any service and you can navigate around without getting too lost because you already know where to expect everything. The other reason being, over time, you'll probably find the pattern that works for yourself and your use case. So even though it might not be like a textbook correct pattern or whatever, it works for your company, for your team. You find your own best practices over time. And then the third one is because those you just reduce snowflakes. Like those services are, if you kind of keep them to a single responsibility and they can be structured in the same way, maintenance is a lot easier, like understandability is a lot easier. There's no snowflakes. You can deploy them in the same way. So that would be my number one advice, is to try and keep them as similar as possible.
Oh, I'm excited because my advice is precisely the opposite. We have conflict. And all good stories involve conflict. So no, this is another question of context, right? And I'm sure, Kat, you've worked in environments where that advice makes perfect sense. And I'm sure I would agree with you in those environments. But in my experience, microservices are a solution to not a technical problem, but an organizational problem. They help you deal with Conway's law, essentially. And the whole point is that you define these like very strict schemas, boundaries between them, like how they communicate with each other, which allow you to implement them however you want. And so like one developer in a given organization shouldn't be working on more than one microservice. A team should own a microservice, right? If you find that like one developer is contributing to multiple microservices, then there's like, in my experience, like something's gone wrong. So like in this world of microservices, the implementation should be like completely up to the team. So Scala, Go, Haskell, whatever.
Yeah, I would largely agree with Peter. I would say there are some exceptions that are actually technical. So if you have systems where certain services need to scale differently than others, that can be a certain example where you might need to split off an application so you can have one have 8 nodes and one have 2 nodes, but maybe your team's not large enough to, split across 2. Another example is if you have a release schedule where you might have an API that's public, you might need to have some kind of versioning that is more restricted on certain services, not others, that kind of thing. But overall, I agree, it's largely an organizational benefit.
Yeah, I think, so again, to introduce the context first, like if we're talking different languages, then yeah, of course, like don't try and shoehorn one language into following another language's structure and best practices, because every single language it should be written slightly differently, right? Like the way it's intended to be written in. So I was thinking of a case where your code base uses one language. It's sort of the same application, like the same system that just consists of a bunch of microservices. And then with regards to the team owning microservices, like the way my company is structured is that teams own microservices, and say a team owns like 5 or 10 different microservices, but then you've got, 5 people in a team and they can each touch that service every day. So to keep one person tied to a microservice is obviously like not future-proof and not scalable. And then because we've got new developers joining the team, we've got people moving between teams every now and then, you just reduce that barrier to entry if they can come in on day one, just recognize the same structure and the same patterns.
Uber gave a talk recently that went into some detail about the patterns they use. I think it was at GopherCon San Diego. Was that correct?
Yeah.
Yeah, they talked about their dependency injection framework and so on. Yeah, and so that makes a lot of sense in that environment, I think.
Yeah, I was talking more about a team of a few hundred engineers and like over 1,000 microservices. So at that scale, I think if we had just a bunch of monoliths, then that would not be scalable. So yeah, I agree that it's mostly to address just how to organize your company in the most efficient way. If you're just a single developer working on your application, I think microservices might be a bit of an overkill, unless you really, really want to explore that pattern.
I am curious though, Kat. So you guys have multiple microservices per team. I've seen that too. I'm curious what's the benefit of doing multiple services versus one single one for the team?
We have our microservices are actually single responsibility, and like they are very, very tiny. So it's not a service that does a bunch of things. It's a service that does one thing and one thing only. And usually it's just the aspects of the team that the team is responsible for. So, like I work at a bank. So let's take lending as an example. Like there could be a service that makes the decision whether to lend somebody money or not. There could be a service that does credit checks. So it's a single responsibility. And then the whole team is kind of working on that aspect of the application of the product. So it's very hard to find the one-to-one mapping between a specific aspect of a team and that service. Like usually you need to touch a bunch of them because they're so small. Like one service is responsible for just one little thing, and usually you take them as puzzles and you join them to build something bigger.
Yeah, and you work at Monzo, right?
I do, yeah.
Yeah.
Yeah, I joined them because I was really, really curious to to basically learn how to do microservices well, because previously my experience was very much like, I don't think that quite works. Like, it's very hard to find what should be microservices. Where do the boundaries lie? And then I wanted to join Monzo because I wanted to see from the inside, like, how to make that happen in a good way. And like, Monzo is a bank, so you can build a bank using microservices. And that's obviously a huge responsibility. So I kind of saw this from the outside and I'm like, okay, they're doing something that works. And now after a few months there, I can see that probably having the homogeneous services, single responsibility services, having every service being owned by a team so that there's no unowned services that nobody knows about, like that, those are some like key building stones, I think, to the success.
So in the case of Monzo then, so you mentioned a service that's making decisions about lending. That's going to internally, I mean, the work is going to be very different to, say, the service that handles when you freeze your card. If you lose your card, you can freeze it. So what's similar? It's going to be the messaging, the interfacing. What actually is similar? And then is it okay that, and probably it has to be that then other things inside that service could end up looking very different?
Yeah, so pretty much the only difference between those services is the handlers, the database schema for the particular service. So if each service has some schema, that will be different. And then the handlers, or like the actual business logic, will be different. That's obvious. Everything else is the same. And like by everything, I mean literally everything. Routing, authentication, authorization, logging, metrics, all of that stuff. Like we use libraries quite a lot. So we've basically extracted all the common functionality into libraries that you pull into each service. And that way every single service is the same. It does the same. It works in the same way. Like if you deploy a new service, it instantly pops up a Grafana dashboard for you because it's spun up in the same way. So there's very little friction to actually add a new service. And again, we use code generation quite heavily for that. So if you just want to start a new service, it's just one command and boom, you have it. And all you have to do is just fill in the business logic. Everything else is taken care of because there's no point reinventing the logic the same, 1,000 times.
Yeah, it's not the interesting thing about that service, is it?
Yeah.
It's just something that you have to have.
Yeah, and the great thing is that as we add more people, they don't need to know the details about, how does routing work or whatever. They can just assume that there are black boxes that work. And then if they want to do something on it one day, then they can explore more and dive in more. But it just reduces that like barrier of entry for new engineers.
So here's a question, and maybe we're getting a bit far afield here, but let's say the common like logging library has a bug fix or a new feature or something. How do you roll that out across the fleet?
You pretty much mass deploy everything. Like our deployments are super easy. It's just, again, one command on the command line. So we can deploy instantly. And we've had cases where we needed to roll something like mostly infrastructure config, for example. We would slowly roll it out across the whole fleet of services. And then you just ask the owning teams to deploy it. So like you prep the fix, you'll merge it, and then you'll ask the teams that own services to just do the upgrade or do the bug fix or whatever and deploy their services. And then we just have a spreadsheet of, what's been done, what's still waiting to do. And you chase the teams until they do it. And like, luckily all the teams are pretty responsive and reactive. So usually we don't take too much time to get it done.
To rebuild and deploy.
Yeah.
So Kat, earlier you mentioned the hex layout, I think you called it. That's really for dealing with dependencies, right? And which dependencies you're allowed to import from where and things. Could you tell us a bit about that?
So I think hex architecture, at least the way I understand it, it's more about separating the different things that make up your application. So some of the application code will be your pure domain logic. It will define your business logic and your processes. Some of it will be framework code. Some of it will be third-party code. Some of it will be the glue between the logic and the third parties. Some of it will be sort of the glue between the framework and your application. So I think it lets you organize your application so that you build boundaries between the domain logic, the application code, and the third party and framework code. And that in turn allows you to make changes without having to change a lot of things just to make one small change. Because if you isolate the business logic, the chances are it doesn't change very often. So it can stay the same. It's well protected by tests, sort of isolated from trivial changes to like frameworks or whatever. And then in the same way, if you wanted to swap the type of database that you use, you just sort of swap an interface to it, but then you don't touch the logic. So it kind of just prevents you from having spaghetti code where different like interests are mixed together, like business logic with like suddenly a call to a database right away and that sort of thing. So that's how I understand it.
I like to describe it as like layers of an onion. Your business logic is in the core, and then everything else is kind of like getting further and further away from the business logic. And at the very outside is, gRPC or whatever. And just like defining those boundaries and being very explicit when you cross them.
Do you end up turning one struct type into another a lot and copying fields across and things? Because that's something you can actually, if two structs are exactly the same structure, you can just cast it immediately, can't you, in Go? But that really doesn't feel like it feels a bit fragile. Are there any other techniques we've used other than just having a method on the struct to turn it into another type? And then how does that work with the avoiding circular dependencies and stuff?
So the way we solved the problem, and that's just one of the possible ways. So instead of having a method or a function on a struct to turn it into a different struct, because that then means that struct has to have knowledge of how does the third party representation look like, for example, if you want to translate like a domain logic, a business logic struct to like a database struct. And it shouldn't care what the database expects. And then equally, like you could have that function done on the database struct. So it takes a domain one and turns it into its own form. But again, like it's kind of weird. How do you decide? So the way we solved it is we just have marshalling packages. It's just a really dumb marshalling kind of like utils package, which just takes a struct of this kind and outputs a struct of a different kind. And then we just have them like available across the service. So it just calls it on the way in and on the way out.
This is a topic of frequent conversation in the like GoKit world. And I think to tie back to an earlier conversation we were having about like evolving a code base as your requirements grow, I think it's just like a question of complexity and like how philosophically strict you want to be in your application, because plenty of people will take their gRPC types and like use them as database models, right? And like you can do that. You can use the same type through all the layers of the hexagonal architecture. It violates the layering principle, right? In theory. But, and like there are consequences to that, but maybe it's worth it rather than writing, the marshalling and unmarshalling code. Maybe that's like too laborious. If you want to be like really strict, you're going to have a new data type at each layer of the architecture, and you're going to write the code to translate it. Maybe that code is just a cast. Maybe that's fine. So like it's just a question of how rigid and strict you want your application to be. If the application is only going to live for a year because you only have 6 months of runway and you don't have product market fit, it probably makes no sense to go through all the struggle. But if you're a Fortune 500 and this code is going to live past your lifetime, then yeah, maybe take the time, because that extra 20 minutes of typing is nothing in the grand scheme of things.
Yeah, I usually put my structs into wherever. I always put it in the package, the dependency, to convert from the domain personally. So I'm usually pretty strict about that. I do have a question though, kind of on this topic. We were talking about controllers and separating the model and all that. So there's a whole, and this is just kind of my thought recently I've seen a lot of people where they will try to make like almost dumb models and they'll have these kind of dumb models where it's just like, oh, store this thing, get this thing and whatnot. And they try to put all their business logic back up, higher up. But I feel like you lose out a lot on like transactions, unless you want to model transactions at your domain layer. And you have just a lot of these little performance improvements and benefits you can get from the underlying dependency, the technology that you're using, that you can't get if you move it up to the controller. So I don't know about struggle, but I mean, I tend to move away from actually like big controllers and actually start putting business logic into the implementations, which I know is supposed to be like a no-no, but like I find from a performance standpoint, it's just kind of, it almost makes sense a lot of times, and transactional integrity, that kind of thing. I'm curious what other people think about that.
Well, it brings up a good question when you talk about those sorts of performance enhancements. I mean, I tend to go for just kind of simplicity and ease of maintainability and things over performance. But of course, sometimes performance really does matter, and it's probably a trade-off. Then you have to sort of decide whether you're happy with this slightly more complicated thing, but performs brilliantly, versus it's very easy to read and maintain, but it's a bit slow. I was very pleased to hear that Defer's got a turbo boost in the recent release of Go, because that was one example where for readability, Defer's. I actually love Defer. We should do an episode just on Defer. I think it's such a brilliant thing. the arguments against defer were it didn't perform great originally, and it's a kind of runtime thing. It's not something the compiler can just do, because I was thinking maybe the compiler could just look at where the defers are and just kind of copy the code essentially to all the exit points. But of course, you could queue up a lot of defers in a for loop, for example, at runtime, and so there's no possible way. Well, sometimes it's possible, but not always. I always preferred the readability of defer over the performance. But what you described makes sense. And actually, if you're squashing things down and just keeping things simple and not breaking all these things into layers early, then you can do that. And I think when it comes time to break that out, you'll know, I think, at that point, it'll make a decision about where that stuff will live. It'll probably be quite clear.
I just want to say, I think the defer episode should be the last episode of Go Time.
It should have been the first.
Oh.
That's a good idea, though. So how do you feel about that, performance over readability?
Yeah, this is a great seg. Like, I think what Ben mentions, like, he exists on a point on the spectrum where, like, performance is important, but the spectrum extends in the other direction where, like, maybe you don't need that performance. And so it's another issue of context. But I think it's a great seg to maybe, like, start talking about performance optimization and profiling and that kind of stuff, which I think is also maybe a topic worth discussing.
Actually, real quick, still on the topic of performance, I guess when I think of performance, like I use defers just, with reckless abandon. Like I never think about the performance generally. But as far as something like, say you have like a SQL database where you could, implement some business logic up in the controller where it would call down and make a bunch of calls over a bunch of transactions within your database, or you could write some crazy, update with a lateral join, something that, executes 1,000 times faster. Like that can have a real impact on, latency and noticeable performance. And that's kind of the pieces I'm thinking of. And it has a transactional integrity. So
for me, the question is always like, in the language of your business domain, what is the action you're performing? Is it that entire transaction, or is it all the specific things? And if it's the entire transaction, that makes total sense to do all that work in a single like call, right? But if, the way you've chopped up the abstraction boundaries at one layer, at the database layer, at the storage layer, it's all these individual things, which your business logic is responsible for stitching together, then, you can do it the other way. So it's a design question, I think, first, and then a performance question second.
Yeah, I completely agree with that, because there is micro optimizations and there is the proper optimizations. And I think a lot of people, especially sort of new to optimizing performance or coding or something, they just tend to focus on micro optimizations because they would, for example, hear that defers are bad because they're slow, and they will just go out of their way not to use them. And that's really dangerous because most of the time you're not really tackling the real problem. You're just masking it. So I would leave those till the end, because very often they will just have such a negligible impact overall that you will just never notice the difference between using defers and not using defers, unless you're doing like live trading or something where like every single millisecond is crucial. And I think that Peter touched on a really important point, which is how you structure applications and exactly that. It's the sequential execution of a business process, or can you actually break it down into a bunch of asynchronous calls that you can make? And also, does everything have to happen in order to achieve point X, or can you maybe defer some stuff later and just get to point X quickly and then do other things? So to give a real life example of that is, and we actually have one of the Monzo guys, Matt Heath, has a really good talk explaining how we've structured our processes. So for example, when you pay with a card in your shop, all you care about as a customer is that the transaction goes through and gets approved by us as fast as possible. And the customer doesn't care at that point about, enriching it with the merchant's logo for the app, or getting the actual merchant name, or any of the nice to haves, but not mission critical. So what we've done is instead of going, okay, first approve the transaction, then I go on, fetch the logo, and then maybe update this or that, or send the user the feed item, we just approve the transaction and return right away, because that's the most important thing. And then afterwards, that kicks off a bunch of events, and then those events are consumed by all the services. And one of them is going to send the feed item, one of them is going to fetch the logo for the merchant, and so on and so forth. But the actual mission critical path is just approving the transaction. And if everything else fails afterwards, we don't really care. We can deal with that. We can replay it, or we can do whatever. It's just that offload that is the critical point. So I think it's thinking about systems in this way that is the really, really powerful skill.
So that's a great example as well of something where the user experience directly impacts the design of that system. And I think that is something that we should do more of. And it's vital that we know the why of what we're building for that exact reason. I love, in that particular case, Kat, I do love it when I pay with my card and the merchant, is that what they're called? The person in the shop is still waiting to get approved, and my watch has already said, yeah, it's fine. It's going to be fine. And they sort of, often sometimes they have to wait quite a while after, and I suppose that's their bits that are being slow. But they don't trust me. I just show them my watch and say, yeah, it's done, bye. That doesn't work, unfortunately, not yet.
Yeah, I do exactly the same. Yeah, and also sometimes there is a third-party restriction. So, for example, the need for actually approved transactions really quickly comes directly from MasterCard. They give you a few hundred milliseconds to respond, and if you don't, they will just cut you off. So it's in your best interest.
This episode is brought to you by KubeCon, Cloud Native Con, and you are invited to attend this flagship conference from the Cloud Native Computing Foundation, KubeCon, Cloud Native Con North America 2019. That is a mouthful and an awesome conference to attend. It's happening November 18th to the 21st in San Diego, California. This conference gathers adopters and technologists from leading open source and cloud native communities. Use the code KCNA changelog 19. Once again, KCNA changelog 19 to get 10% off registration, or check the show notes for a special link to register and also a link to the Convince Your Boss letter. Again, check the show notes for links to learn more and register. And by Linode, our cloud server of choice. It's so easy to get started with Linode. Servers start at just $5 a month for your big ideas. Head to linode.com/changelog. Choose your flavor of Linux that works for you. Then pick a location that's right for you. London, Tokyo, Dallas, and many other places in the world. They've got you covered. Go from having that amazing shower idea to a hosted website in just minutes. Start small, expand as your idea blossoms into a huge hit. And we trust Linode because they keep it fast, they keep it simple. Check them out at linode.com/changelog.
I can ask a related question, like a sort of new question, but an interesting one that I've actually been thinking about as well, which is, personally, how often do you actually end up writing the really concurrent code using concurrent patterns in your day-to-day job? And that leads to like a different question, which is, should you design your applications with concurrency to start with? When should you introduce it? Like, should you overcomplicate it? Well, overcomplicate it in that sense to start with, or do you just start sequentially and then branch out? Like, what's your take on it?
Yeah, I mean, usually when I design stuff, I'll make the sequential piece that actually executes. I'll usually kind of make that part of the export API of whatever the thing is, and I'll try to make the fancy, concurrent version of it. Just call into that, and kind of it just makes it so much easier to test, to be able to see the sequential stuff and separate it out from the actual concurrency pieces. But usually I'll start with the sequential stuff until it's just too slow.
If I'm writing a package, I will try and avoid concurrency altogether and let the users do the concurrency. You know how easy it is to just sort of say, go do this thing. You can't always do it, but that's my goal, is if I can just not have any concurrency in this package and let that, a bit like where the state lives, as Peter mentioned, let that be just in one place, then I'll do that for sure. Otherwise, I tend to have all the concurrency bits in one little function, and it calls out to other things so that there is still one place. I did it before when I first started with Go. I was so excited about channels. I just used them all over the place, and I definitely overused them. And actually now I end up using mutexes and Go routines essentially most of the time. But sometimes channels are a lovely interface and they just fit perfectly, don't they? And they are very exciting times because I do love using channels.
That actually reminds me of a talk, I think, at GopherCon 2018 in Denver. And there was a talk from somebody from the Go team, I can't remember now, and he was talking about advanced concurrency patterns. And he actually mentioned this as one of the important things, which is if you're writing a package or a module that is to be used by other people, don't build the concurrency into it. Write functions that can be run concurrently by the consuming code. And that was like a great mind shift for me as well. So it's, instead of like putting concurrency in, just write a function that can be safely run in a concurrent way. And then the consumer will decide whether they want to do it concurrently or not.
Yeah, for me, it's about the fact that the user then knows exactly what's happening there because they did it. I'm very anti-magic, despite having the appearance of a magician. which I'm well aware of.
Do you do that deliberately, or is it just emergent?
No, but it is tough being, I had to come out to my parents. I was like, Mum, Dad, sit down, pick a card. It's very difficult to come out as a magician.
I thought you were going to say, Mom, Dad, sit down. I'm going to Hogwarts.
That's a hate crime. No, I didn't get in.
It's a tough school. Who was it that mentioned Hemingway earlier? I forget.
I think it was me.
And was it? I'm going to be a little bit gross here now and say, I think Hemingway is a great, model for writing code, because I think the best code is always that which is, so, plain and simply stated that there can be no ambiguity about what's going on. And I think that's actually a target for me when I write packages and code is, it's little things like how many levels of indent are there? 1? Perfect. Can I read it like it's a short story? Do this or that. Then this, then that. And designing concurrency into the API is part of that as well. I should be able to say, my package exported functions are usually verbs, do this. My package exported types are usually nouns, this thing. And combining those two should be a very orthogonal sort of process. And if my package doesn't look like that, because I haven't quite mastered my expression of it, then I need to rewrite it, right? And so concurrency is something that I almost always leave out of everything I write. The only time I write Go, the keyword Go in most of my programs is in func main. There are some exceptions, if I need to, I wrote something recently that did a lot of scraping of third-party APIs, and there's no reason to do that sequentially. So I wrote kind of a little future thing, and it go'd a bunch of HTTP gets and then recombine them and that kind of thing. But that's the exception, not the rule.
Yeah, I kind of found out a similar thing that in my coding katas or little side, fun projects, 24 days in December or whatever, then you experiment with those cool concurrency patterns and fan in and fan out in the channels and all of that. But actually in the day-to-day job, the concurrency is built more into the system itself rather than the code. The code is most of the time is sequential, and because we have tiny services, usually there's just not enough even things to do concurrently. It's just a one simple thing. And then to quickly touch on the previous subject of do you have controllers, models, and everything else, or do you just have the logic in the implementation, or the implementation in in the model itself, or do you skip the model entirely? I think it also depends on the size of your service, of your application, because if it's a big one, you might even need crazy submodels. I've worked on projects which had crazy models of models because they were monoliths essentially. Whereas in the smaller the service, I find the less layers you need. So sometimes it's completely fine to just go have a thing that is both a controller and a model that just goes to domain. If you don't need those two, then just don't force them, because it's just unnecessarily complicating things. So yeah, that was kind of the thought to the previous question.
That is great, though. I think I'm so pleased you said that, because I know for a fact that people, they feel like that's a failure if that happens. They feel like they haven't solved structure, they haven't architected it properly, because they don't know what they're doing. That's how people feel about this. And it really isn't the case. Yeah, I agree. I genuinely will start nowadays with just a single folder. Everything's in main. I don't even break it out into packages in the beginning. Even when I know for sure it's going to have to happen. It's a sort of journey. That's the thing. It is a journey. It's not that we're building for the final state. We're never really building the final state of anything in software. So I'm really pleased you gave that example.
Yeah, and whenever I talk about DDD and you talk about the different components in DDD, the repositories and the services and the value objects and whatever, and some people will try and desperately find every single one of those in their application, and sometimes you just don't have them, and that's completely fine. It doesn't make you a worse programmer if you don't have those things. Sometimes you just don't.
And I think the DDD is the final form of the structure of a program. It's also it depends on you having a really strong command of your domain. If you're an early stage startup, you don't even know what you're building. You don't know what the people want. You don't know the models you need. And so there's no reason to go all in on all this structure, right? It's only in the final stages when, you're presumably making profit and you have customers to tell you what you want, then you can harden all of your models of the thing you're actually building. And until then, it's nonsense and a waste of time to go that deep.
I hope that gives a level of comfort to our new Go programmers that listen. I really do. I love that this has been basically the theme of this show, actually.
Yeah, and to repeat once more, just don't expect to get it right from the start. You'll almost definitely get it wrong. You'll almost definitely have to go back and change some things. So yeah, I think it goes back to what Peter said at the start, which is just write your code in a way that is easy to change, and then just don't be afraid to change it. The code just lives and morphs all the time. Like your business logic will change over time as well. Like if you're building a product, like a software as a service type of thing, like you'll probably add some features over time and remove some features over time. So your actual, business domain will also change, and that's fine. And then you have to adapt.
There's another article, I don't know if giving all these call outs is good or bad, but I think my favorite article ever written on the theory of like software engineering and programming, I don't remember the exact title. I'll share a link maybe for the show notes. But the number one point in it is that like business requirements never like settle down and become static. They always change. That's the nature of business, right? So you can't like program in the hope that asymptotically you'll approach the truth. All that's going to happen is the business people are going to throw more changes at you, right? So like understand this is true and program to that truth.
I love that. One thing we haven't talked about much, which is a big thing in Go, is interfaces. And again, this is an area where in the past I've definitely made mistakes where I just made everything an interface. Everything I did was an interface. In fact, my packages, even if I had a greeter struct that was going to do the greeting, I would have a greeter interface in there as well, and then anyone else could use that interface, That was kind of confusing. People would, I didn't actually build greeters, but I did build real examples of this, and people would often ask, when do I use the interface? When do I use this concrete type? So it added a kind of bit of noise, and I must have picked up from somewhere, possibly one of you three or Dave Cheney or somebody, saying, yeah, don't bother with the interface. Just have the concrete type. If the user needs the interface, they can write their own. That's a really interesting property, I think, of the way Go's interfaces work. They are kind of duck typing, although apparently it's called structural typing because it's a compile time thing. It doesn't happen at runtime. As long as the concrete type or the type implements the same methods with the same signatures as what's in your interface, then you can use it in place. And that as a property, I think, really helps. But what about dependencies and dependency injection and things like that? How do we feel about interfaces there?
I like interfaces a lot for that. I think a few things on interfaces. Like I think one thing that people tend to get wrong early on is that they define interfaces by the library defines the interface versus the caller. And I think that's probably one of the biggest things that people usually need to overcome to really kind of get that to snap and understand it. So, I think for interfaces, generally, I don't use interfaces unless I need two of something, two implementations of it. And a lot of times it can be like, hey, I'm running Postgres and I have that, but I also want a mock version of that. So, you can interchange both of those. And not to get too far, but on the topic of dependency injection, since we're talking about that, I know Uber has their own dependency injection framework. I've looked at it a little bit, but honestly, I found that just writing code and just like instantiating things and just passing them in inside of main tends to be the best, most straightforward dependency injection I've seen. That's what I do.
Yeah, it's another question of context, right? Like when I heard about Uber's talk, I was like, are we really going to go down this road again? But hearing it and understanding like the context of their organization, I think it makes sense there actually. In the same way, like Kat, you have a lot of microservices. It doesn't make sense to rebuild the world for each of them. It's kind of their environment. On the subject of interfaces, I use them extensively, but as consumer contracts, not as producer declarations of intent. So what is the aphorism? Like return structs and accept interfaces. I'm probably on the far end of the spectrum, but yeah, I do that all the time. And Ben, you mentioned like you only need an interface when you have two of something. For me, when I take dependencies into a constructor or a function, I always need two of them because I have the real thing that I use in prod and then the mock or the fixed whatever test thing in every dependency of mine. There's always two of them. So I always use an interface and I define it next to the function or constructor or type that uses it. Yeah.
I've done that before where I had the interface was in the test files. It didn't even get into the main package because in this particular case, I think it made sense. I like also the fact that you can define interfaces inside the functions as well.
Like anonymous interfaces.
Yeah, kind of. And there's a storytelling opportunity is what I was going to say. It's clear then looking at the test what's kind of expected. And so, I like those sorts of little things which Go enables. Sometimes I've done it and I've thought, this is clever, really clever, and I feel really good about myself. But actually, no one's going to expect this to be the way it is, and I just pulled it out and did it the boring way. But for a while, I was happy, and those sorts of patterns, I think, are really kind of cool.
Happiness is fleeting. Grab it while you can.
Yeah, exactly. That's true, actually. I think even, like we talk about premature abstraction and premature optimization and things like this, sometimes I would be quite forgiving if somebody's just really into an idea and they want to just make this thing perform brilliantly. It's not a business requirement, but I think happy developers should be a business requirement. And so I'm quite forgiving if someone's got a little interest in something or an idea about something, they want to explore it. I'm very into that idea, and I always try and encourage them to then talk about it and share that experience as well if they can. So we can all hear about it too.
Yeah, I think it's the right thing to do to encourage people to profile their applications, because you might just find out that there's nothing to optimize, but just knowing that there's nothing to optimize is very valuable. So I think you should definitely profile your application and then find the real bottlenecks and then focus on those. Because if it's a tiny project, zero-stage projects, you might be able to optimize whatever you want. I think that in your full-time job, the business will always say, like, focus on the most important thing, because we don't have time to fix everything. And then you just really have to pick the most impactful fix to make.
I'd actually love to see a talk. This is a challenge to any of our listeners. I'd love to see a talk where we show some code and ask the audience, like, where's the performance problem in here? Like, manufacture some issue and then actually use the tooling to look at it. And often, you'd be very surprised by where the actual problems are. I'd love to see that as a talk. It could be really, really fun to watch.
Yeah, I always think that it's very important to just have proof for your guesses as well, because sometimes you might think that this is causing problems, but actually you'll find that not really. Sometimes we had a really interesting talk at the last London Gophers actually about visualizing the performance of your tests. It was about running tests in parallel with the T-dot parallel. Eleni showed a really, really cool visualization of how the tests are executed, like on the timelines. And you could actually see in which case they were truly executed in parallel. And if you had subtests, they actually were executed in a sequential way, which was little bit of a surprise. And you might be thinking that, if I just put a T-dot parallel in my test, they will magically be faster. It very much depends on what your tests are actually doing and how they are structured. So that was really cool to see.
I agree with the premature optimization piece, but I think one thing that I found to be really helpful over the years is there's you can Google it, but just type in latency numbers every programmer should know, and there's a couple different versions of it. You can even get like historical ones, but it basically shows you everything from the time of like an L1 cache hit to like reading disk from a spinning disk to going over network, and just to see the scale of like how that it could be like a nanosecond to do like an L1 cache hit, and it can be milliseconds or microseconds or whatnot to do these other things. And just the places people try to optimize where it's like, I don't want to check this variable with this error statement. It's like that will take you 3 nanoseconds or something. Like just do it. So it gives you a little context about where all this stuff really matters.
Yeah, or worrying about stack versus heap allocations.
Well, this has been very insightful. I've definitely learned a lot. I hope lots of our listeners have too. Specifically, I like this thing about don't abstract too early, keep everything as simple as possible and let the patterns emerge, let the architecture emerge, and make decisions later. Defer and use defer. So if anyone wants to reach out to any of our guests, Twitter's a good way to do it sometimes. It's a free website. Kat, what's your Twitter name?
I'm going to have to spell it out very slowly. So it's at KASIAZIEN, which is my Polish name.
Brilliant. Very high scorer on Scrabble as well. Ben, what's your Twitter name?
On Twitter and pretty much everywhere on the internet, I'm Ben B. Johnson. So just Ben, B as in boy, JOHNSON.
Great. Peter?
So I actually have 2 Twitter accounts. My programming and bad millennial jokes account is at Peter Bourgon, just my full name. And for my acting career and weightlifting, you can find me at The Rock.
Really? Great. I hope you 3 will join me again in the future. That's all the time we've got for today. We'll see you next time.
All right, thank you for tuning into this week's episode of Go Time. If you're not yet, hang with us in Gopher Slack. We have a channel called GoTime FM. Look it up, you'll find us. Hang with us during the live shows, connect with other members of the community, share stories, share code, share coffee recipes, whatever. It's a lot of fun. Also, we have discussions at changelog.com on every episode. Head to changelog.com/GoTime, find this episode, and discuss it with the community. Also, thanks to Fastly, our bandwidth partner, Rollbar for helping us move fast and fix things, and Linode for hosting the Changelog platform. Our music is produced by the mysterious Breakmaster Cylinder. And if you want to hear more awesome podcasts like this, subscribe to our master feed. It's one feed to rule them all, plus some extras that only hit the master feed. Head to changelog.com/master or search for Changelog Master in your podcast client. You'll find us. Thanks for tuning in. We'll see you next week.